Hi friends, it's Sarojin here. Welcome to my networking channel. Hope all are doing good. And today the topic I am going to discuss about shaping. So what is shaping? Shaping implemented at the customer end and it is used to shape or buffer the traffic to a certain bit rate. So without shaping, if I am sending the traffic towards ISP or the police can drop the packets. So what happen? Assume the packet we are sending towards ISP and what happen if the packet rate if the bit rate exceeds this link bandwidth, what happen? It will drop the packet. So to prevent the egress blocking or to prevent the police from dropping packets at the ISPN, always better thing is we have to shape the traffic and we have to send it up towards the ISP. So that is the purpose of shaping. So let us understand the terminologies. So what is shaping? There are three terminologies you have to understand. One is time interval. So this is the time in milliseconds for every committed burst. So what is BC? BC is the amount of traffic sent during a certain time interval. So this is the BC. So each and every traffic interval will be sending the amount of traffic. So that we call it as a BC. Each and every time interval will be sending the traffic what we call it as a BC. So this is a BC and this time interval is in milliseconds. So what I'm doing, so a single time interval. So this is a 1000 millisecond. So 1 second I'm dividing into 8 intervals. So each and every interval will be 125 milliseconds approximately. So what happened? We'll be sending the data at that physical bitrate only. Physical bitrate is 128 kbs, but overall we'll not be sending all the times the data. So overall on average we'll be sending only 50% of the time. So that means I want to explain this. So 50% of the time we'll be sending the data and again passing the data. So again we'll be sending the data, again we'll be passing the data. So only the first 62.5 millisecond will be sending the data and the next 62.5 millisecond will be passing the data. So this is 125, right? So the first 50% will be sending the data, the second 50% will be passing the data. So also keep it in mind the time at the beginning of every time interval I'll be adding BC. BC is a committed burst. So each and every time will be fill the bucket with the tokens. So first we'll fill the bucket with 8000 bits. So assume this is an 8000 bits. So as per this calculation, this BC is 8000 bits. So at the beginning, 8000 bits will be added at the to the token. That is a bucket token. So then we'll be spending the tokens. Again, we'll be passing the data. So the second time will not be sending the data, right? That is the next 60 to 5 milliseconds. At that time, we'll be again refilling the bucket with the again 8000 bits. Then again, we'll be sending the data. So again, the bucket will be empty. Then we have to refill the bucket with the tokens. Again, it will be sending the data. So this is how. So overall, what happened? This BC I told is 8000 bits. So totally, on an average, we'll be sending 64,000 bits. That is equivalent to 64 kbs. So out of 128 kbs, I'm shaping the data to 64 kbs. So that is the purpose of shaping or buffering the data to a certain bitrate. So this is the shaping on an average. So how to exceed this shaping thing? So that is done using shape p command. So that means what happened? The advantage of having a bigger bucket. So what is that bigger bucket? So I'm going to explain that. So instead of sending BC, we can also add another bit BE, what we called as an excess burst. So assume there is a period of inactivity, there is no data. So assume there is no data previously. So there is a period of some inactivity. So at that time, some buckets are accumulated at the token. So assume there are some buckets already, 8000 bits are already there. So each and every time interval, we will be adding again 8000 bits. So the advantage of having a bigger bucket is what happen in the first time interval, I can send more data than BC. So BC only will be sending 8000 bits. Since I'm sending the excess data, so that is the purpose of shaping with the excess bus. Sometimes the data traffic will not be smooth all the time. Sometimes you have to send the excess data. So for that reason, I have to have a bigger bucket with BC plus BE. So BE will be 8000 bits. Assume B is again 8000 bits. So in the first time interval, within 128 millisecond, I can send 16,000 data at a stretch. So again, I can send it 8000 bits. Then again, I can send 16,000. So that is the way we can send the bits more than BC. So that is the purpose of having the bigger bucket. So that is the thing we call it as a shaping with excess burst. So I hope you are understanding what is the purpose of shaping with excess burst. So I'm going to show how to configure it in the specific router R1 and R2. So the line speed is 128 kbps. I have configured this 1.1 and 1.2. So this is the customer end and this is the provider end. And here I connected two hosts. So for host to host connectivity, what I have done, I have done the static routing, right? So what I'm going to do, I'm going to initiate ICMP traffic. Before that, I'm going to configure the shaping. So first we'll create the class command and after that we'll create the policy map for shaping. So how to do that, I'm going to show that. So this interface speed, right? So let us go here. So this interface serial 2 by 0, I have specified the clock rate of 128,000. What is that? 128 kbps I told, right? So that is the actual interface speed. So I have to configure the same interface speed on both customer and the provider. So that's the thing I have done on R1 and R2. So R2 also I have done with the same line rate. That is the physical interface speed, right? So after that, let us create the class command. Go to the configuration mode. So let us create the class command, class map followed by class 1. So let us configure the ICMP protocol, match protocol ICMP. So after creating that class map ICMP, then I have to map the class name to the policy map. So these are the three criteria we'll do in the configuration, right? First we've created a class map. So then we'll create the class map is nothing but for classification of traffic. Second thing, I'm going to create the policy map, save name policy. So then we have to map the class name. So policy is nothing but we have to define the level of service. So in this policy map, what I'm going to do, I will map the class name. Then I will create the shape command. So I'm going to shape the traffic, right? So I'm this shape command, I'm going to peak the traffic. I'm going to allow excess traffic. So that is the purpose of peak command. So let us add say 90,000. I'm adding 90,000 excess traffic. So total bit rate is 128,000, right? So I'm adding 190,000. So now what I'm going to do after doing this, I'm going to map to this corresponding outgoing interface, that is serial 2 by 0, right? So go to interface serial 2 by 0, then service policy output policy, right? So now let us see show policy map. How to check is show policy map interface serial 2 by 0. So this is the thing I have done, right? So this is the thing. So target average rate is the shaping rate. So we already had shaped to 90,000. This is a 1,80,000. So the byte limit is, it will be BC plus B, total byte limit. Then sustained bits is nothing but the BC level. This is the BC bits. So these are the sustained bits. Excess bit is I already told. It is the advantage of having a bigger bucket. Will be adding BC plus B. So that is the excess bit is 7920. So this is a total byte. And this is the interval time. Interval is always in the millisecond. That is a TC. It will be always in the milliseconds. So this is the number of bytes packets and the number of bytes which will be entering the packet, which will be entering the shaper. So now let us initiate the traffic. So I'm going to initiate the traffic now. So now you can see the changes here. So now you can see the packet flow here. So now you can see here number of packets enter the shaper is 3 and number of packets enter number of bytes in the form of bytes is 264 bytes, right? So what happens when the shaper is active, it will show is active. That means when it exceeds a certain bit rate, automatically this will be active and the packets will be queued. So once it enters a certain bit rate, so that is the benefit of shaping, right? Shaping is used to buffer the traffic to a certain bit rate, and also shaping delays the excessive packets. So when there is an excessive packets, what happen? It will be buffered or queued in a queue. So once the bandwidth is available, then the packet will be taken from the queue and it will be sent on this wire. That is a physical wire. That is the way it works. So first the data will be buffered and sent on the wire. So then again it will queue the traffic excess packets. Then once the bandwidth is available, it will send the packets from the queue to the wire. So this is how the shaping works. So shaping is used to buffer the traffic to a certain bit rate. So now you're understanding, right? These are the number of packets and number of bytes entered. So once it is started queuing, you can see the packets delayed and bytes delay. So why delay is, already I told shaping will delay the excessive packets and it will create the delay. Because of buffering the data, it will create the delay. So that delay it will be shown in this corresponding delayed packets and in the form of bytes. So and also once it is active, it will show shaping is active. So this is how we can configure shaping with the excess burst. So that means it will allow the excess traffic. In the first interval, it will be allowing more bits than BC. So BC the committed burst and it will be adding BC plus B. So totally around on average 16,000 bits I can send in the first time interval. So that is the benefit of shaping up to excess burst. So I hope you enjoy this video. Thanks for watching. Please subscribe for more videos. Thanks and have a wonderful day. Thank you.